Let's go with the concept of multimeter as a ohm meter. So the galvanometer is converted into an ohm meter by connecting a battery and a suitable resistance in series. So this was the galvanometer and this was the ohm meter. For galvanometer, you can find G symbol in a galvanometer, and for an ohm meter you can find this ohm symbol. So if a battery of 1 voltage is connected in series and the galvanometer shows full deflection, then the total resistance in a circuit will be of 1000 ohms. So on the resistance scale 0, which is marked against the current of 1 millimeter. So if an unknown resistance is connected between the terminals T1 and T2, then the current passing through the galvanometer decreases to 0.5 milliamp. Then the unknown resistance will be 1000 ohms. Hence 1 kilo ohm is marked against 0.5 that is milliampere, or else we can say this as milliamps. Now let's discuss about the measurement of resistance. If a galvanometer current is 0.25 milliampere for another unknown resistance connected between this T1 and T2, then that resistance is 3000 ohms. Hence 3 kilo ohms is marked against 0.25 milliamps, that is milliampere. Usually an adjustable resistance of small value is connected in series so that the zero adjustment can be made even if the EMF of the cell decreases slightly. Apart from this, in order to measure the alternating current voltage and current, a rectifier unit is connected in series. So this is the indication, and by turning a switch to AC, the instrument is going to be used as the AC quantities. If the switch is turned to DC, that is DC current, which is called as direct current, the rectifier unit gets disconnected and the instrument is then used to measure DC current and voltage.